If you haven't already heard, our solar system is currently host to a strange and intriguing visitor. Comet 3I/Atlas burst onto the astronomical scene in early July 2025, first identified by the NASA-funded Atlas Survey Telescope in Chile. Since then, scientists across the globe have assembled to collect every scrap of information they can get, leading to a flurry of new papers and a fair share of controversy about the first interstellar object to enter our cosmic backyard in 6 years. But amid this media frenzy, what have we actually learned? What information about this comet is true, and what lies in the realms of science fiction? I'm Alex McColgan, and you're watching Astrum. Join me as I give you a much-needed update on 3I/Atlas, piercing through the noise and getting to the heart of what makes this visitor so special, just in time for its October 30th perihelion. When I made my first video about 3I/Atlas back in July, there were only around 4 published research papers naming it. Now we have nearly 70. This represents a huge boost in our collective knowledge, but before I dive into the newest findings, let's do a quick recap. 3I/Atlas is named for its status as the third interstellar object to visit our solar system, following Oumuamua and Borisov. In contrast to its two predecessors, 3I/Atlas is thought to be much faster, traveling at a whopping speed of 58 kilometers per second and significantly older, with estimates that it is somewhere between 3 and 11 billion years old. Since its debut, countless hours of observation from astronomy facilities have unveiled much more. NASA's Hubble Space Telescope was granted urgent time to observe the comet, capturing images that revealed the teardrop shape of the dust coming off its icy nucleus. Crucially, these observations allowed scientists to make new estimates for the size of 3I/Atlas's nucleus, measuring it at most 5.6 kilometers in diameter. This is a significant finding as it's much smaller than original estimates, which mistakenly assumed the comet's reflectance was coming entirely from the nucleus. The James Webb Space Telescope, JWST, also jumped in using its spectrograph to determine the comet's composition. Researchers found a complex coma suggesting that carbon monoxide and carbon dioxide were sublimating more than water at this stage, a pattern that is expected to shift as the comet moves closer to the sun. Perhaps the most surprising insight came from the transiting exoplanet satellite TESS. Astronomers realized TESS had observational data for 3I/Atlas all the way back to May. By analyzing this data, researchers found that as the comet got closer to the sun, its brightness surged by a factor of 5, not the expected 1.5. This shocking surge suggests that 3I/Atlas is far more active than we originally thought. This means it may have been releasing hypervolatile compounds like nitrogen or hydrogen, possibly even when it was 6 astronomical units away from the sun, near the outer limits of where comets usually start outgassing. Discoveries have also been made by telescopes back on Earth. The Gemini South Telescope in Chile successfully visualized not just the coma, but the comet's growing tail. Crucially, the observation session collected the comet's spectrum, revealing an emission feature proving that it was releasing cyanide molecules. By measuring the ratio of dicarbon to cyanide in the coma, scientists placed 3I/Atlas as one of the most carbon chain depleted comets we know of. Since carbon chain depletion reflects the conditions of a comet's formation, and Borisov also shared this feature, this may hint at a common pattern in the composition of these interstellar travelers. In a new paper, Zuri Gray and colleagues presented the first ever polarimetric observations of 3I/Atlas. Polarimetry is used to probe the physical properties of space objects, such as the size of their dust grains and the structure of their surface. They found that 3I/Atlas has an exceptionally deep and narrow negative polarization branch. This finding is monumental. it means that 3I/Atlas is scattering light in a way that has never been seen before for any other comet or asteroid in our solar system. This unique behavior sets it apart even from Borisov, suggesting it may belong to a distinct class of small planetary bodies that we know next to nothing about. At this point, we must address the major controversy, the speculation pushed by renowned astrophysicist and Harvard professor Avi Loeb. Loeb has suggested that 3I/Atlas could be alien technology. His argument centers on the claim that the object is too large to be an asteroid and explores the idea of engineered, possibly hostile alien maneuvers. However, Loeb's hypothesis has been met with a strong criticism. The core of the critique is simple. Loeb continues to base his arguments on outdated, early estimates for the comet's size, ignoring the more credible peer-reviewed data from Hubble. Furthermore, other scientists have successfully shown that the comet's trajectory can be explained far better with natural dynamics than engineered maneuvers. We've come to the end of our reunion with 3I/Atlas, but the research moves almost as fast as the comet. On October 30th, the comet will reach perihelion, though sadly it will be too close to the sun for observation at that time. Don't panic, it will reemerge by early December, ready for a renewed bout of in-depth analysis from missions like SOHO, SPRE-X, MAVEN, and continued observations from Hubble, James Webb, and the Gemini Observatory. It's a race against time to answer the remaining questions. How will its activity change as it reaches perihelion? Will it break apart? And can we trace its elusive origin? Solving the mystery of Comet 3I/Atlas is only possible by finding patterns in the data. It requires analyzing mountains of data, spotting subtle patterns, and testing ideas against the evidence.